Today we're going to start the first application of derivatives, the antiderivative. It's a process of going back. Now, there's a couple ways to do this. So if f is a derivative, and really it's a function, some functions aren't differentiable, but then we say big F is its antiderivative if and only if, when you take the derivative of big F, you get little f. Okay, so let's do a couple things. Let's talk about the derivative of x squared. It's 2x. Let's talk about the derivative with respect to x of x squared plus 6. It's 2x. Notice these are the same, but these functions aren't. Let's talk about the derivative with respect to x of x squared plus any constant. It's 2x. So the derivative is not unique. Which means its inverse process, so to speak, also is not unique. But how do we note this? Well, okay. I'll fix that later. So if f of x is 2x, now if you think about it, when you're taking the derivative of something to a power, you bring the power down, you keep the variable, and you subtract 1. So when we're going backwards, instead of losing a power, we're going to gain a power. Now let's think about that. If you take that derivative, that m plus 1 comes down, and we divide by the new power, and we add a constant. So let's prove. Big F prime of x. It's 1 over m plus 1. Oh, the m plus 1 comes down. X to the m, and the derivative of a constant is 0. And oh, look, you can check, because the derivative of an antiderivative is the first function you started with. So in our case, we're going to gain a power and divide by the power. Don't forget to add your c. The reason this is called an arbitrary constant, we don't know what it is. There are ways to find it, and those are called initial value or boundary value problems. So let's think about this. If I took the derivative of e to the x, it was e to the x. So the antiderivative of e to the x will be e to the x plus constant. Now there are some properties that transfer, so to speak. If I don't know, how about we have 5x to the 12th? Okay, I'm going to leave the constant alone. Oops, wait 1 second. Antiderivative. Okay. Now I'm going to go factor the scalar out. I gain a power. I divide by the new power, and I add the constant. So this is 5/13 x to the 13th plus constant. Okay. Okay. Now the derivative of an exponential is the exponential times the natural log of the base. So the antiderivative of this exponential is the exponential divided by the natural log of the base, and then we add the constant. Oops, I better fix this. Okay. There's one other symbol that's called antiderivative, and that's the indefinite integral symbol. So this is the indefinite integral. Indefinite integral. Now when you write it this way, the first thing you put is the function. That's called the integrand. And then you're going to put a dx or dy or whatever. This is called a differential. So that's the variable you're taking the antiderivative with respect to. So you just have to play with this notation. Okay, so with the antiderivative of e to the x. Well, that's e to the x plus c. Now, it just so happens the derivative of a sum is the sum of the antiderivatives. Well, the antiderivative of the sum is the sum of the antiderivatives, because derivatives and antiderivatives are linear operators. So when you have, and we use f of x a lot, so the antiderivative of the sum or difference of two functions is the sum or difference of the antiderivatives. And I really need you to focus on the vocabulary. If you have a scalar multiple and you want the antiderivative of a scalar multiple, you can factor out the scalar. Okay. Well, let's do a couple challenging ones. Well, let's think about this. The antiderivative of e to the u is e to the u plus constant. So I know it's going to be a 2x, and I know I'm going to add a constant. Now, wait 1 second. If I take the derivative of 2x, because this would be a chain rule, a 2 would pop out. I don't have a 2 there. So what do you multiply 2 by to get 1? A half. Well, let's check. d dx of 1/2 e to the 2x plus constant is d dx, I'm going to factor the 1/2 out, plus d dx times the scalar of the constant. This is 1/2 e to the 2x times 2 plus 0. Notice I ended with my integrand, so this was an antiderivative. There's a natural check built in. I hope this helped. We're going to start doing more of this in class because this is going to be very important. If you haven't learned all your derivatives, your shells, go learn them. Because if you know how to take derivatives, antiderivatives is not so bad.